All right, we're going to talk about functions. So a relation, which meaning an equation, is a function if there is one output for each input. It is not a function if one input has more than one output. And so we will see some examples of this. Think of it as a function machine, right? You put something in, the function machine does something to it, and then you get something out. The input is called the domain. These are the x coordinates. The output is called the range. These are the y part of the coordinate. Once again, every input must have an output. If you put something in, something has to come out. You could put something in and it can have an output. You could put something else in and it can have the same output. However, you can't put one thing in and get two things out. So one input has to have one output. So we'll look at these. Which set of pairs is a function, right? So 9 is your input, 10 is your output. -5 is your input, -2 is your output. 2 is your input, -1 is your output, and 3 is your input, and -9 is your output. This is a function because every input has only one output. Let's look at this one. 6 is your input, A is your output. 8 is your input, F is your output. 6 is your input, B is your output. -2 is your input, P is your output. This is not a function because 6 has an output of A and 6 has an output of B. If you put a 6 in there, you can't get both A and B out. So this is not a function. And then the last one, Z has an output of 7, Y has an output of -5, R has an output of 7, Z has an output of 0, and K has an output of 0. This is not a function because Z as an X coordinate, right? Z as an input has both 7 and 0 as an output, and that cannot be true. No two ordered pairs can have the same first coordinate and different second coordinates, right? Can't do it. So we'll look at it in a similar way. Here's our input, and here is our outputs, right? So you put in -3, you get 3. You put in 1, you get 1. You put in 3, you get 1. You put in 4, you get -2. This is a function because two different inputs can have the same output, but it's not the opposite way. You can't do it the other way. Function? Yes. Each input is mapped to only one output. Look at it the same way. -3 gives you 3. 1 gives you -2. 1 gives you 1. And 4 gives you 4. 1 cannot give you two different outputs. One of these inputs cannot give you two different outputs. So, function? No. Input 1 is mapped onto both -2 and 1. So try this out for yourself. See what you think. All right. 2 is mapped to 5. 3 is mapped to 8. 4 is mapped to 6. And 7 is mapped to 20. Each input has only one output. So number 1 is a function. Here you have 1 mapped to 4. And 1 also gives you 5. 1, a single input cannot give you two different outputs. So this is not a function. Let's try this one. Each one is mapped to only one output. Now the outputs are all the same, but the output can be the same. The X coordinate cannot be the same. The Y coordinate can be the same. All right, vertical line test, right? This is a way to tell from a graph if something is a function, right? If the vertical line hits the graph or more than one point, then it's not a function. So here's a graph of 4 points, right? Draw a line through this point. It only reaches one point. Draw a line through here, and it hits two different points, so it cannot be a function. It is not a function. Here's your vertical line. It touches two separate points, so this is not a function. We'll try this one. Vertical line, right? Only 1 point, only 1 point, only 1 point, and only 1 point, right? Yes, it is a function. So we'll check these graphs out one at a time. Is it a function? Yes. Is this a function? Yes. Vertical line test. Is this a function? No. Right? Vertical line touches multiple points. Is this a function? Yes. Vertical line only touches it. Is this a function? No. Vertical line test. Is this a function? Yes. Right? And what about this one? Definitely not. The vertical line is the whole graph, so it definitely not a function. Right? Right here, it's going to touch multiple points. Right here, it's going to touch multiple points. What about this? Yep, that's a function. All right, let's talk about function notation, right? Function is f of x, function of x, f of x. Input is x, the output is the function of x, which is the same thing as y. So when you see f of x, it really just means the same thing as y, right? So here's a function, y equals 6 minus 3x, right? This is your domain, this is your range. It's the same thing. Nothing has changed except for the notation, because y is actually the function of x. It's what you do when you use this variable. Input and output, same stuff. All right, so when you see this kind of notation, f of x is equal to 2x squared minus 3, and it says find f of 0, that just means plug in 0 for x. So 0 squared times 2 minus 3. Negative 3 squared times 2 minus 3. And 5 squared times 2 minus 3. Right? So we'll just do 5. 5 squared is 25. Right? 25 times 2 is 50. Minus 3 equals 47. That's how you find it. So 5 is your input. That's your x. And then 47 is your output or your y. And so let's talk a little bit about the limitation of the domain, right? So in certain kinds of equations, we have to limit what can be part of the domain, what can be an x coordinate, right? And we'll look at those. All right. So in this case, it can be, you can put any number, any real number you can put as x and you'll get an actual response. In this case, since we know by a rule that a denominator cannot be equal to 0, x can't be 2. It can be anything but 2. So you say that x can be anything, right? This is just the notation, anything but 2. Because 2 minus 2 is 0. You cannot divide by 0. Here, right, you're looking at the square root. You can't take the square root of a negative number. So x has to be anything greater than negative 6, right? Because if it's negative 6, that's going to be 0. Greater than or equal to negative 6. Negative 6 plus 6 is 0. You can't take the square root of 0. But if x were to be negative 7, which would be greater than negative 6, then negative 7 plus 6 would give you negative 1. You cannot take the square root of -1, right? So we'll find these domains, right? X squared plus 2, once again, you can square any real number. And so we'll always get a response with this function. So it's all real numbers. Here you can't, once again, you cannot take the square root of a negative number. So any number over here has to be greater than 1. Anything less than 1, such as 0, if you plug in a 0 for x, you're going to get a negative number. You can't take the square root of a negative number. So x has to be greater than or equal to 1 to make sure this number's never negative. And then here, you know that your denominator cannot be 0. So this will be all real numbers except the number -5. And that is that. So now we're going to check out some linears. We're going to look at linear equations so that we can, check that out, right? So slope-intercept form, right? We've talked about slope-intercept form. So we figured out, if equation is linear, we figured out functions, and now we're going to talk about taking that onto the step of graphing and slope-intercept form, right? We talked a little about slope-intercept form. You can find out all kinds of things that you need to know about a graph from slope-intercept form, and you can figure out all the points along that graph if you have slope-intercept form, right? So we know slope is rise over run. This is a negative slope. You have to attach that negative to either the numerator or the denominator, but not both, right? So it's rise over run. Your y-intercept is 4. We know that that means that the graph intersects the y-axis at 4, and this is a positive 4, so it will happen right there. So in order to graph this line, you plot this point, right? 4, that's where you know it intercepts the y-axis, and then rise over run, right? So it's -2/5. So it's a negative rise, which means you're going to go down 2, and then it's going to be a positive run. So that's 5. So 1, 2, 3, 4, 5. Plot that point, right? There we go. And then draw the line through the 2 points. And there you go. You can graph that line if you know the y-intercept and if you know the slope. -2, -5. And this, when you have your line graphed and you have if you draw in the rise and the run, that makes a right triangle. So here we got the same thing, right? Same thing. We're going to graph this line. We have a slope of +4, right? And that's going to be written, if you want to do rise over run, that's going to be a fraction 4/1, and it is positive. So it's a positive rise and a positive run. So we're going to graph it, right? It's a negative y-intercept, so we're at -1/2. And then we're going to do the change in y and the change in x. Rise over run. So we'll plot another point. Rise 4, so we're going to be at 3.5 because we were at -1/2, and then run of 1, so we're going to go over 1. Plot that point at 3.5, 1 or 1, 3.5, and then draw our line, and we have our graph. Same thing. Same thing. If you have your graph paper, go ahead and try and do this graph. Pause the video, try and do this graph using your slope, which is 2, which once again, it's a +2. It will be written as 2/1. So your rise over your run, 2/1. And you know that the y-intercept is -3. That is where it intercepts the y-axis. So go ahead and pause the video and try and graph this for yourself. Draw in this line. Okay, we're back. We know our y-intercept is -3. So plot that point, 0, -3. And then we know our slope is rise over run, +2, +1, rise of 2, run of 1, and then we can draw in our line through those 2 points. Slope-intercept form. Same thing, pause the video and try and graph this line. All right, here we are. Our y-intercept is +1. Plot that point. And then our slope is -2/3. Once again, the negative sign can either go with the 2 or with the 3. It really doesn't matter. Most of the time, we do it with the top, with the numerator. So our negative rise, which is, so we're going to go down. And then our positive run, we're going to go over. So we've gone down 2 points, over, plot our point, draw on our line. If you know the slope of a line and the y-intercept, you can also write an equation. Y = mx + b, right? Slope of 2, y-intercept is 3, m, which is your slope. And you know where the point is? You can indeed. This is the slope formula, right? M is equal to the change in y, right? So if we're using coordinates, if we're using our points, we could, if we had 2 points, we'd be able to find out what our slope is, and we'll do that in a minute, right? You don't know 2 coordinates, so you can't use that formula, right? Now this is some algebra, right? We want to take this, solve for y, so we'll have it in our slope-intercept form, right? When you have all of this down here, right, x - 0, you can't, it's all the denominator. So you can't get rid of one piece, you have to get rid of all of it. Of course, x - 0 is x, right? So we simplify that, x - 0 is x, because anything, when you subtract 0 from it, is the same. And now we want to, since we're dividing by x, we're going to multiply by x to remove that denominator. So we'll get 2x, right? 2x is equal to y - 3. We got to add 3 to both sides, right? Because we're trying to get y by itself over here. And we get 2x + 3 is equal to y, or you can also write it this way, whichever way is more comfortable, right? But we've solved for y. This is now in slope-intercept form. So we now know that we have a slope of 2 and a y-intercept of 3. And here is our slope-intercept form linear equation. Y is equal to mx + b, where m is our slope and b is our y-intercept, right? You can write any linear equation, any equation that is going to be a line, you can write it in this form. All right, so here we are. We're just going to write the equation that describes the line in slope-intercept form. We know the slope is 1/4. We know the y-intercept is 4, and we're going to sub these things in for y = mx + b. Slope is equal to m. Y-intercept is equal to b. Y = 1/4 x + 4. This is the linear equation for the line that has a slope of 1/4 and the y-intercept of 4. Try this one on your own. Pause the video, write it in slope-intercept form. Same thing. Just plug them in. -9 is our slope, and our y-intercept is -5/4. We simplify this, right? Y = -9x - 5/4. So we know our y-intercept is negative. Same thing. Try this one. All right. We're just plugging in our values. Slope is 3. And our y-intercept is 1/2. Y equals 3x plus 1/2. And the same thing here. Notice that you have a negative slope and a negative y-intercept. We're just going to plug those numbers in where they go. Y equals -1/4 plus a -6, which simplifies to y equals -1/4 x minus 6. All right, now we're going to write the equation that describes the line in slope-intercept form. We know our slope, and we know that the point 3, 4 is on that line. So we need to find the y-intercept. Y equals mx plus b. Substitute 2 for m and 3 for x and 4 for y. So you know y equals mx plus b. You know what m is. It's your slope. It's 2. They've given you a point on the line. 3 is your x coordinate. 4 is your y coordinate. And you are just plugging it into the equation y equals mx plus b. You can plug in 3 for x, plug in 4 for y, and then you're solving for the variable b. 4 equals 2 times 3 plus b. 4 equals 6 plus b. Subtract 6 from both sides. You get b is equal to -2. So -2 is your y-intercept because b is the variable that represents the y-intercept. And so you know the y-intercept is b. We're going to do the same thing here. Slope-intercept form. Y equals mx plus b. 2 is our slope. That is going to be our m. 3 is our x. 4 is our y. And we are solving for b. So we plug in those numbers, and if you solve it, you get your answer of -2. Once you plug in 3 for x and 4 for y, and you solve that equation, your answer to that is -2. So you know b equals -2, and then you plug it in. I did not show you the solving of the equation because we've solved a ton of equations, so you can do that. And that's where we are. All right, same thing. A line has a slope of 8, and the point 3, -1 is on the line. Write that equation in slope-intercept form. So give it a chance. All right. Now that you've done that on your own, after pausing, we're going to write it in slope-intercept form, right? So you know, substitute 8 for m because that is your slope. Substitute 3 for the x because that is the x coordinate in your ordered pair, your coordinate pair. Substitute -1 for y, and then solve for b because you're looking for the y-intercept. 8 times 3 is 24, right? Then you're gonna get, so you get -1 is equal to 24 plus b. Subtract your 24 from both sides, and you get -25 is b. Now you're gonna write the equation because you know all the things that go in the equation now. Y equals mx plus b. The m is your slope of 8, and then we solved and found b. Y equals 8x minus 25. So here we go. Y equals 3x minus 1. Finishing up here by, okay, so y equals 3x minus 1, right? So you know that your slope is 3, which is 3 over 1. You know that your y-intercept is -1. So we're going to plot our point. Then we are going to use our slope positive 3 over 1, positive rise over, plot our next point, and graph our line. Drawing our line. All right, here we're going to write the equation in slope-intercept form, and then we're going to graph. So in order to write an equation in slope-intercept form, you have to solve the equation for y. So we have to do some of the things we've learned previously with our solving of equations in order to solve this equation to get the y by itself. So we're going to subtract 3x from both sides in order to remove it from this side, right? We want it to get it away from the y because we're trying to get y by itself. So subtract 3x from both sides. 3x minus 3x is 0. It leaves us with 2y. Over here, we get negative 3x plus 6 because this is a positive 6. Still have to get the y by itself, though. So we have, this is a two-step equation, right? Now we're going to divide both sides by 2 in order to, right? We're multiplying 2 times y. So we need to divide by 2. You do that. These 2's cancel out. And then you get negative 3x plus 6 divided by 2. Negative 3 over 2, right? Negative 3x over 2 is equal to negative 3 halves x. 6 divided by 2 equals 3. So we have our equation, y is equal to negative 3 halves x, remembering that negative 3 halves is our slope. And then plus 3, remembering that plus 3 is our y-intercept. And now we are going to graph it. In order to graph an equation, a slope-intercept form equation, we are going to plot our y-intercept, which is positive 3. And then we are going to use our slope, negative 3 over a positive 2. So we're going to go down 3. And we're going to go 2 units to the right. And we are going to plot another point. And then we're going to draw in our line connecting the 2 points. And that is graphing a line when we have an equation in slope-intercept form, right? Same thing here. Try and do this on your own. We're just going to graph this line. It is already in slope-intercept form. Notice that there is no plus b. There is no y-intercept, which means the y-intercept is 0. So we're going to graph the line. For our y-intercept is 0, we plot that bad boy right there at 0, 0. And then we have a positive 2, positive 3 on our slope, up 2, and to the right 3. Plot our other point, and draw in our line. All right, this one is definitely going to be one for you to do on your own. Pause the video, solve for y, and then graph your line using the equation in slope-intercept form. All right. Now that you've done this on your own, we're going to solve this equation. So we're going to get rid of this 6x over here because we want to get our y by itself. So we're going to subtract 6x from both sides. Gives us 2y on this side of the equal sign. Negative 6x plus 10 because that's a positive 10 over there. Now we still have to divide by 2 because we've got to get this y by itself. Divide everything by 2. And we will reduce this down to y equals negative 3 over 1 x plus 5. Now we're going to graph that line. We have it in slope-intercept form. We're going to plot our y-intercept. Then we have negative 3 over 1. So we're going to go down 3 and to the right 1. We're going to plot our other point, and then we're going to draw in our line. All right. Y equals negative 4. y equals -4 is technically in the slope-intercept form. You only have the y-intercept. You do not have a slope. So plot your point. Since the slope is 0, we're just looking at a horizontal line, right? 0 over 1. So whenever you're just given the y-intercept, it's a horizontal line because the slope is 0 over 1. All right, we're going to check this one out. It's a word problem. A closet organizer charges a $100 initial consultation fee plus $30 per hour. The cost as a function of the number of hours worked is graphed below. Write an equation that represents the cost as a function of the number of hours, right? $30 per hour, so it's going to be 30x. And then if the initial consultation fee is $100, that will end up being your y-intercept. Y is equal to $30 per hour, 30 times x, plus your original $100. Write it out like that, and you have your equation. Now, as an additional part of the question, let's identify the slope and the y-intercept. Y-intercept is 100. That is the cost for 0 hours because the x coordinate is 0. So it's 0 hours worked. The slope is 30, and that is the rate of change. It is $30 per hour. If the organizer works 12 hours, which means that's going to be your x coordinate, plug it in for x. 30 times 12 plus 100 equals 460. That is $460. All right, try this one on your own. Pause the video and try this one. All right, a caterer charges a $200 fee plus $18 per person served. The cost as a function of the number of guests is shown on the graph. You will notice immediately that your y-intercept is 200 because 200 is the original fee. That is your starting point for 0 anything else. $18 per person served, that is going to be $18 times x because x is unknown. You don't know how many people you are serving. Y equals 18x plus your original $200 because that is your fee for 0 people. And that is your equation. Y equals 18x plus 200. The slope and the y-intercept. So in this case, the y-intercept is 200. That is the cost for 0 people. That's the initial fee of $200. The slope is 18. And that is, once again, the rate of change. Rise over run, the rate of change. $18 because it's $18 for every person. So as the amount of people change, so does the rate or the cost of the catering. So if we have an event for 200 guests, right? The amount of persons is our x. So we're going to sub that in for our x. And that will help us find our y. That is our cost, $3,800. The cost of catering for 200 people is $3,800. All right. You can try these. You're going to write the equation that describes each line in slope-intercept form. We know our slope is 3. Our y-intercept is -2. So our equation in y-intercept form is y equals 3x minus 2. Slope is 0. Y-intercept is 1/2. So that equation is just merely y equals 1/2. And then now our slope is 3/2. 2, 7, or our pair of 2, 7 is on that line somewhere. So to solve this, you have to determine what the y-intercept is by plugging your slope into y equals mx plus b, y equals 3/2 x plus b, and then you're going to plug in 2 for your slope or your x coordinate. So it'll be, and then 7 for your y. So it'll be 7 is equal to 3/2 times 2. plus b, you're still solving for b to find your y-intercept, and you will get 7 equals 3 plus b. Subtract 3 from both sides, and you should get 4 is b, and then you plug in what you know into your equation. And now perform these operations. Here, you need to solve for y, and that will give you the equation in slope-intercept form. And then you're going to graph it. Same thing here, solve for y. You want to get this y by itself. In this one, don't forget, this y has to be positive. So it's best to move the y over here and then move the 6 over here. So pause the video and do that. And here we go. This will equal y equals negative 3x plus 5. This will end up equaling y equals x minus 6. Here, get your positive 5 as your y-intercept. Then 1, 2, 3 down, over, and then draw the line through. And then here, negative 6. And then your rise over run is just 1 over 1. So you get that diagonal line.